Today we're going to be finishing up Unit 2 with our lecture on 2.6, which is we're going to be solving our quadratic equations using the quadratic formula. So at this point I want to go over a little bit of what we've done. So we have solve by taking the square roots. You can't do that for every type of example. But if you can, it is a really good shortcut. And we did that in sections 2.1 and in 2.4. Solving by factoring, where we take out a GCF if we have it, we reverse FOIL, right? We kind of end up with two parentheses side by side. We did that in sections 2.2 and 2.3. Last lecture, we solved by completing the square. That was 2.5. And then today we're going to be solving by quadratic formula. So the quadratic formula is a great catch-all. If you're kind of struggling with figuring out what is the best way to solve, the quadratic formula will work each and every time. But students often make a lot of arithmetic mistakes while they're using the quadratic formula. So I encourage you to really take your time as you're doing this. On the test, you will be expected to solve using all of these different methods. After this test is over, on any upcoming questions throughout the rest of the school year, you can use whichever approach you like best. So let's go ahead and solve just with a warm-up by completing the square. So that was from sections 2.5. So I encourage you to pause the video and try this one on your own. I'm going to take half of my b value and square it, which is 25. I then rewrite this as a binomial squared. Since it was a negative 10x, it becomes an x minus 5, the quantity squared. Then take the square root of both sides, and I get x minus 5 equals positive or negative, square root of 17. And then add 5. So my final solutions are 5 plus or minus the square root of 17. So when you solve the quadratic formula, you're going to get answers like this. And unfortunately, those would not be acceptable answers on an ACT nor on an Algebra 2 test. You're going to have to know how to simplify these down. So here's my recommendation on how to do it. We are first going to simplify the radical as much as possible. So with this radical, there is a perfect square that goes in there. Unfortunately, the biggest perfect square that goes in there is just a 4. So 4 times negative 1 times 62 will give me negative 248. And I put these on the outside because I know the square root of 4 can come out of the square root, and the square root of negative 1 is just I. Now, last but not least, in order to simplify this down, you need to have all 3 corners have something that is divisible into all 3 of them. And notice I did not circle what's under the radical. What's under the radical will have to stay under the radical. Even though it's an even number, it's not 62, it's the square root of 62. But since these 3 are all divisible by 2, I'm going to divide all of them by 2. So I get out negative 2 plus or minus I square root of 62 over 6. Now that would be an acceptable answer. I see a lot of answers on an ACT that look this way because they know you're using the quadratic formula. Technically, you could simplify this some more. If you broke this fraction out, I would get negative 2/6, which I can simplify that down to negative 1/3. That should be a plus or minus. So either of these answers, this one down here, are acceptable, or this one up here are acceptable. Now I took up a lot of space answering that question. Let's look at our next one. I need to simplify the square root. I need to actually do this subtraction. So 4 minus negative 10, well, that just ends up being 14. Because there is no perfect square that divides into 14, this is an acceptable answer. I do not have 3 corners, so I cannot simplify this down. If you do want to simplify it, you could put 30 under both of these, which negative 2/30 would simplify down to negative 1/15. And I know we're going to see that even number under the radical, and you're going to want to simplify it, but either one of these answers would be acceptable. All right, let's get into our instruction for this particular topic. So we're going to calculate what is called the discriminant. The discriminant can be calculated by taking b squared and then subtracting 4 times a times c. And you say, well, where do these letters come from? Remember, our quadratic equation is ax squared plus bx plus c. So that's where the a, b, and c comes from. And the discriminant, if I just calculate our discriminant value, it's going to tell you the number and type of x-intercepts or solutions or roots or zeros that your quadratic has. Are they real solutions? Are they imaginary solutions? That is what the discriminant will help you to determine. So if you take our values for a, b, and c and calculate b squared minus 4ac, you should get out a number. You will usually get out an integer. If that integer is greater than 0 or a positive number, that means that you have 2 real solutions. That means you're going to have 2 real x-intercepts. And that looks, right, if I were to graph this on a coordinate plane, that would mean my parabola goes through my x-axis 2 times. If I calculate b squared minus 4ac and I get out 0, that means I have only 1 real solution. And if I were to plot that parabola on a coordinate plane, I'll do this one upside down, that means it's only going to hit the x-axis in 1 location. And last but not least, if I get out a negative number when I calculate b squared minus 4ac, that means I have 2 non-real solutions. And that means that my parabola never, ever, ever hits the x-axis. My x-intercepts exist in a different plane, the complex plane. So let's go ahead and look at some examples. Say I just want to determine the number and type of solutions. And by type, I mean real or non-real. And notice that these examples are all very similar. The only thing that's different is that c value. Remember, our quadratic equation is going to be written in this form. And I need to set y equal to 0 because I'm finding x-intercepts. Right? We did that with linear equations, and we're going to do that now. So notice these have all been set equal to 0 already. The a value is the number in front of the x squared, which is 1. The b value is the number in front of the x, that's a negative 6. And my c value is my constant. I then am going to evaluate or calculate the number of b squared minus 4 times a times c. A negative times a negative, remember that's a positive, so I get 36 minus 40, which is negative 4. Because I got out a negative number, I'm going to use the table right up above that says if you get out a negative number, that means you have 2 non-real solutions. Or 2 non-real, right, x-intercepts. Looking at our next example, my a value is equal to 1, my b is negative 6, and my c is 0. So I'm going to calculate b squared minus 4ac. I get out positive 36, so that means I have 2 real x-intercepts. I have 2 real solutions. And then on our last example, I have a is equal to 1, b is negative 6, c is 9. So when I calculate my b squared minus 4ac, I get 36 minus 36, which is 0, so I have one real solution, or one real x-intercept. So in the word problem below, I just ask you to figure out if the solutions are real or non-real. So I came up with an equation right here about a ball being thrown in the air at a certain velocity of 14 meters per second and an initial height of 2. Now, since I just pulled those numbers out of thin air, did I pull good numbers? Remember, this is supposed to be a real-world example. If it's a real-world example, then I should not have imaginary solutions. I should have real solutions. So I'm going to set this equation equal to 0. And notice I'm using a t instead of an x. It really doesn't matter. But here I can pull out that my a is negative 4.9, my b is 14, and my c is 2. So if I calculate b squared minus 4ac, then I get, right, a negative times a negative is going to end up being a positive number. I get 196 plus 39.2. That equals a big positive number. So that means I'm going to have two real solutions. So that tells me when I kind of came up with this word problem out of thin air, I did a good job. I picked numbers that will give me real solutions. So remember, our quadratic equation is going to be ax squared plus bx plus c, and I have to set it equal to 0. I have to move everything over to the other side of the equation. In order to calculate the quadratic formula, remember we're just finding our x-intercepts, but this is a formula that you have to memorize. It is a catch-all. It works in every situation, and I always like to sing a little song that helps me remember it, and it goes to the tune of Pop Goes the Weasel, and it goes like this. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. So don't worry, as I go through this, I will sing that again and again. Make sure you have the exact same equation in your notes. And you'll notice the value that is under the radical is that discriminant. That is our b squared minus 4ac. Because it is under the square root, that's why it can help us determine if our solutions are real or non-real. Let's look at our first example. Well, I have to make sure that I set this equal to 0. So I'm going to subtract 8 from both sides. I then go ahead and identify my a value, my b value, and my c value. And then I plug it into our quadratic. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. Then let's go ahead and calculate this value out. What do I get? Pick up my calculator as well. Minus 4 times 3, negative 8, 196. So that's a nice round number, all over 6. So I get negative 10 plus or minus. Now the square root of 196 is just 14, all over 6. So that means this equation here, I could have solved by factoring because I'm going to get out some nice answers here. I have a plus or a minus, so I'm going to rewrite this as negative 10 plus 14 over 6. And you really only have to do this if you get out integer answers. If you get out an integer from your square root value, then I do make you simplify it down. Negative 10 plus 14 in my numerator is 4. And then I'll simplify that fraction down. Here, I get a negative 24 divided by a 6, which means here are my two x-intercepts, 2/3 and negative 4. Let's go ahead and do our next example. I kind of ran out of room, so I'll write it on another page. I already have it nicely set up, set equal to 0, so I just need to identify my a, my b, and my c. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. Now a couple things to note with this one. I start out my song with opposite b. And I say opposite b because if it's a negative, it becomes positive. If it was a positive, it would have become negative. I also wrote this negative 10 within a parenthesis because negative 10 squared without that is negative 100. When you're performing this operation, it's thought of as two separate things. You raise the 10 to the power and then you multiply by negative 1. So that is why I want to make sure that I know that it is the quantity negative 10 squared, which is a positive 100. So just little things like that. That's where arithmetic mistakes can happen on these types of questions. I get out 68 under my radical. And now I have to see if I can simplify. But before I do, I have to simplify the square root of 68. That is 4 times 17. So I get 10 plus or minus 2 square root of 17, all divided by 2. Then I'm going to simplify this down by dividing everything by 1. So my final answer is 5 plus or minus the square root of 17. You may have noticed that this was the exact same question from our warm-up. Our warm-up question had this. See if I can go back and see it. And notice we got the exact same answer. It's important to note, right, that these are all different ways of doing the same thing. We should always get out the same answers regardless of what we use to solve. Let's go ahead and do letter C. Well, I need to move everything over, so I'm going to subtract 17x and I'm going to add 25. So I get 16x squared minus 40x plus 25 equals 0. So I get my A is 16, my B is negative 40, my C is 25. X equals opposite B plus or minus the square root of B squared minus 4AC all over 2A. Now when you calculate what's under your radical, you're going to end up with just a 0. So because the square root of 0 is just 0, my final answer is just 1 x-intercept. Notice that if my discriminant is 0, I just get out 1 answer. Let's go ahead and do letter D. And I encourage you to pause the video and try these on your own before I do them. Have to set it equal to 0. My A is 1, my B is negative 7, my C is 3. X equals opposite B plus or minus the square root of B squared minus 4AC all over 2A. I just get a 37. Now because the square root of 37 cannot be simplified, I am all done. That is my final answer. Oh, let's do letter E. My A value is 3, my B is 2, my C is negative 3. X equals opposite B plus or minus the square root of B squared minus 4AC all over 2A. Because the square root of 40 can simplify down, right? It's the square root of 4 times the square root of 10. I get negative 2 plus or minus 2 square root of 10 over 6. Now I have the 3 corners here, so I can simplify that down. So my final answer, and you need that -1 out front, that is a number. You do not need the 1 in front of the 10. That would be just a placeholder. So this here is my final answer. If you haven't already done so, I encourage you to try the last one on your own. I'm going to go ahead and use another piece of paper here. I'm running out of space. That's what happens with the quadratic formula. I have a equals 2, b equals -1, c equals 3. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. I get -23 under my radical there. And the only thing I can simplify down is I can take out the I value. And my final answer, in this case, we have imaginary or non-real solutions, is 1 plus or minus I square root of 23 over 4. Let's go ahead and do a couple of word problems. So these application problems, you will not have to memorize equations or formulas for word problems. We will give you those equations. But I wanted us to write down some of these equations, and these are based on if our application problem are in feet. Because we have to consider gravity when we're throwing an object or dropping an object, it's important to note that these equations are when we're working in feet. So our formula says my height at a given time, that this is just function notation. It just means your ending height is equal to -16 t squared plus my initial height. This just means initial height. Do not let that confuse you. Now my height at a given time, if I do have something being thrown, well, I have to consider the velocity at which it is being initially thrown. So not only do I have my initial height, I also have my initial velocity. So get those two equations down. And let's do 2 examples together. So here we have a basketball player passing the ball to a teammate. The ball leaves the player's hands 5 feet above the ground. So that means my initial height is 5 and has an initial velocity of 55. And then the teammate catches the ball, or it returns to an ending height of 5. So I'm going to use that second equation. And when I plug my values into that second equation, it should look something like this. Okay, so I'm going to subtract 5. And I would encourage you to try solving these using factoring, right? Instead of necessarily using the quadratic formula, which is what this lesson is all about, you can definitely solve this by factoring. You just take out your GCF. But because we're doing quadratic formula, I will stick with our theme here. Notice I do not have a C value. So it wouldn't be x equals, it would be t equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. So when I do that, I get -55 plus or minus the square root of 3025, which is just 55, over 32. Sorry, -32. So I've got two branches I need to follow. I have -55 plus 55. Well, that just gives me a 0. So that means at time 0, the ball was 5 feet high. That makes sense. The ball left at a height of 5. So that's why at the initial height, it was. Now this one, I pick up my calculator and make sure to calculate and get negative 110 divided by negative 32. Let me make sure. I get out 3.4375 seconds. So that means it's going to take the ball 3.43 seconds to be thrown from one player to the other. Haley drops an egg from the top of a building 50 feet above the ground. How long does it take for the egg to hit the ground? So we are going to use our first equation, and our ending height is going to be 0. You could definitely solve this by taking the square root, and actually let's do that. Let's mix it up a little bit. I want to isolate my t squared. So I'm going to subtract 50 from both sides. Remember, there's so many different ways. We could have done the quadratic formula, but this one is such a nice example to do using square roots. I get t squared, a negative divided by a negative becomes a positive. So then I just take the square root. So I pick up my calculator. I don't even need to simplify this because I only want answers in decimal form. I also do not have to consider plus or minus because a negative time does not make sense in the context of the problem. So when I do the square root of 50 divided by 16, I get out 1.77 seconds. So that concludes 2.6 and Unit 2.